Now that we've seen how we balance chemical equations, we're going to take a look at the different types of chemical reactions. So the table right here lists 5 different types of reactions. We have a synthesis reaction, a decomposition, a single replacement, a double replacement, and then combustion reactions. So then it gives us this general equation for each of these. And so a little bit of a guide to read this. A single letter represents an element. 2 letters combined represents a compound. And it doesn't have to be A's or B's. It could be the C or a D. But then we get an example equation with real elements and compounds. So we're going to take a look at each of these now. A synthesis reaction, the word synthesis means to build. And so synthesis reactions build compounds. This is a chemical reaction in which 2 or more reactants combine to form a single product. So for example, we have sodium plus chlorine to produce sodium chloride. And so when you look at the chemical equation here, a couple things to notice. We have that coefficient 2 out front of sodium and out here in front of sodium chloride to help balance the equation. So fun fact about sodium, it's a very reactive metal, and it will explode in water. And chlorine is a poisonous gas. When they are synthesized together, they form table salt. Another example would be when we take, we have nitrogen monoxide plus oxygen to produce nitrogen dioxide, which is kind of like a smog over big cities. Your second type of reaction is a decomposition reaction, and this is a chemical reaction in which one reactant breaks down into 2 or more products. For example, we have carbonic acid, H2CO3, and that forms when carbon dioxide dissolves in water. And so this happens when atmospheric carbon dioxide dissolves into the ocean, and it gives the ocean a little bit of carbonic acid. So as the amount of carbon dioxide in the atmosphere has increased over recent decades, this has resulted in the acidity, because of carbonic acid, being put into the ocean. Another example is when we break down water into the hydrogen and oxygen molecules, and it will only break down when an electric current is run through it. And so if we have a beaker of water and we run a current through it, we can trap oxygen and hydrogen in some test tubes. The replacement reactions, this is when chemical reactions in which ions switch places in one compound, which would be a single replacement, or in 2 compounds for a double replacement. So a single replacement is a type of reaction when one ion switches places with another. So you're always going to start with a lone ion, and it will then get incorporated into a compound, and then you'll end with a different ion being alone. So in this case, potassium, the highly reactive metal, is combining with water, which produces the potassium hydroxide, a colorless solid, and then some oxygen gas as well. And you can watch that reaction at the link below. A double replacement reaction is when you start with 2 compounds and you get 2 new compounds. So a compound, and 2 new compounds because they switch ions. So sodium's a plus ion, as is silver. They're both plus ones. The chlorines are minus, and so is fluorine. And you'll notice then that they switch the positive and their negative partners. So sodium now pairs with fluorine, and calcium now pairs with silver. The last type of reaction is a combustion reaction. This is a chemical reaction in which a substance quickly reacts with oxygen. When this happens, it will produce carbon dioxide, water, and either light or heat, or it could be both. These are really reactions that burn. The substance that burns is referred to as the fuel. So the fuel will also be a reactant in addition to the oxygen. Heat and light are usually produced. So your first example here is when you have a hydrocarbon, and a hydrocarbon is a compound that only contains hydrogen and carbon, like your fossil fuels. And so if we have methane, which is CH4, or your main component in natural gas, so that's your fuel, reacting with oxygen, and it will always produce that carbon dioxide and water. Another example would be glucose. So here's that fuel. When it reacts with oxygen, it produces carbon dioxide and water. So glucose is a simple sugar, and the combustion of glucose is known as cellular respiration. This is an important process that provides energy for life. And the glucose, so glucose, comes from plants during photosynthesis. And every living thing uses glucose and will use cellular respiration. So it's a very important chemical process.